Sounds crazy, doesn't it? But have you ever wondered, is our Earth the only oasis of life in the vast ocean of the universe? Or are there billions upon billions of other planets out there nurturing life forms beyond our wildest imagination? This isn't just a philosophical question. It's one of the greatest mysteries in modern cosmology. The question, is life rare or common in the universe? Not only underpins planetary science, but also touches on profound inquiries into the very nature of human existence. Defining the question and its context. First, to approach this question scientifically, we need to clarify. When we talk about life, what exactly do we mean? Are we referring to life as we know it, organisms that rely on water, carbon, and DNA to survive and evolve? Or should we broaden the definition to include potential life forms based on silicon, ammonia, or entirely different conditions? Life as we know it. Current science focuses largely on carbon-based life forms because that's the only model we can observe, Earth. Common characteristics include organization, energy metabolism, response to the environment, reproduction, and evolution. Life as we don't know it. However, researchers are increasingly expanding the outlook with the concept known as weird life. The hypothesis that entirely different biological systems could exist, such as those based on silicon instead of carbon, or capable of surviving in extreme temperatures and pressures. Reasons to believe life is common in the universe. The sheer number of planets. As of 2025, astronomers have discovered over 5,000 exoplanets, planets outside our solar system, and that number increases every year, with an estimated 100 billion galaxies in the observable universe, each containing hundreds of billions of stars, most with planets. There are potentially trillions upon trillions of opportunities for life to emerge. Habitable conditions are not so rare. It was once believed that a planet must lie within the habitable zone to support life. However, discoveries of organisms living at the bottom of Earth's oceans, near volcanic vents with no sunlight and extreme temperatures, have shattered this assumption. Life may be more adaptable than we previously thought. Life emerged quickly on Earth. Earth formed around 4.5 billion years ago. Evidence shows life began just 300 to 500 million years later. This suggests life can emerge relatively easily when conditions are right, rather than requiring billions of years to develop. But why haven't we seen any signs? The Fermi Paradox. This is the most famous paradox in astronomy. If the universe is so conducive to life, why haven't we seen anyone else? Hypotheses explaining the Fermi Paradox. We're looking the wrong way. Perhaps aliens don't use radio waves, or they communicate in ways we cannot detect. They exist but remain silent. Some civilizations might deliberately hide to avoid threats, similar to prey hiding from predators. They've destroyed themselves. Advanced civilizations might self-destruct due to war, climate change, AI, or other technological catastrophes. We're too early or too late. Perhaps we are pioneers, or maybe we arrived after most alien civilizations have already perished. Biological and chemical evidence. Organic molecules in space. Scientists have discovered organic molecules, the building blocks of life, in interstellar dust clouds, on comets, and even on moons such as Enceladus and Titan, Saturn's moons. Amino acids in meteorites. Many meteorites that have fallen to Earth contain amino acids, indicating that life's ingredients may be widespread throughout the solar system and possibly the entire universe. Studies of Mars and Europa. Mars once had liquid water, and Europa, a moon of Jupiter, is believed to have an ocean beneath its icy crust. These are prime candidates in the search for extraterrestrial life. Overlooked but fascinating angles. The time-scale problem. The universe is about 13.8 billion years old, while modern humans have existed for less than 300,000 years. Other civilizations may have existed millions of years ago and vanished. We simply don't overlap in time. Life in gas giant atmospheres. Some scientists propose that organisms could live in the atmospheres of gas giants like Venus or Jupiter, where dense clouds and unique chemistry might support exotic life forms. Genomes not based on DNA. Earth life depends on DNA and RNA. But alternative genetic systems might exist, such as peptide nucleic acid, PNA, or TNA, genetic frameworks that don't rely on the structures we are familiar with. The universe as a laboratory. One theory suggests our universe may be a simulation created by a highly advanced civilization. If so, life might only exist in select test zones within this lab, purposefully limited by design. Conclusion: is life rare or common? There's no definitive answer, but current evidence leans toward life is likely to be common in the universe. However, intelligent life capable of communication and interstellar travel may be exceedingly rare. We may be like lone explorers, flashing a light in the cosmic dark, hoping for a signal in return. But sometimes the real mystery isn't that we haven't seen them. It's that we may not yet understand how they exist. And the next time you gaze at a sky full of stars, remember, somewhere out there, someone might be looking back at us, wondering the exact same thing.